As you can see in the diagram, the incident ray is going from air into glass, and as that happens, you can see that the ray is changing direction. That change in direction is called refraction. Two ways in which the light waves change as they pass into the glass. Well, the first and most obvious one is if you look here, you can see that in air the waves have got a long wavelength compared to their wavelength in glass. That's a much shorter wavelength. So my first point is that the lambda decreases, lambda the wavelength decreases. It's not enough to say that lambda changes. You have to state how it changes, and you can say that the wavelength decreases or the wavelength gets shorter. The second thing that you can see here is that in air has got a low optical density, and that means that waves are going to travel faster than in glass, which has got a high optical density. So the second thing that you could have said there is that the wave speed decreases. Again, it's not enough to say that the wave speed changes. You have to say how it changes, and it's that the wave speed decreases. There is one more thing that we can say, but first I'm going to have a go at questions B1 and B2, and then I'm going to come back and explain the third part. B1, it says draw the normal to the incident ray on the diagram. Okay, now the normal always should be right at the very point where the ray enters the new medium, and it's always drawn perpendicular to the medium. Okay, so that angle there should be 90 degrees. Okay, so the dotted line is the normal. Mine's sloping a little bit. Okay, it should be 90 degrees. Okay, next bit, label the angle of incidence. Well, there's the incident ray, and we always measure the angle of incidence between the incident ray and the normal. So there's the angle of incidence. Okay, so that's taken care of these two here. Okay, now let's come back to A part 2 and have a look at the third way in which the light wave changes. Okay, you can see here that as it goes in, the angle changes. All right, and you can see that here the angle of refraction is actually smaller than the angle of incidence. Okay. Okay, so there you go. You can see that the angle of refraction is smaller than the angle of incidence, which means that the ray has been bent towards the normal. Okay, and the reason that that's happened is because you've gone from a low optical density to a high optical density. Low to high gets bent towards the normal.